Yo, what's up, everyone? It's your boy Crackathon, bine. Sa Crackathon, bine. I have an analytical chemistry exam tomorrow. Let's see. Let's see what we got. The question was, what was the question? Calculate PCO2. Calculate the PCO2 values of titration 25 milliliters of 0.15 moles of CO2 plus solution with 0.034 EDTA of pH 6 when 50%, 100%, 110% have been titrated. What are these values? To calculate PCO2 values at different stages of titration with EDTA with pH of 6, we use complexation equilibrium and taking into account the conditional formation constant. The volume of CO2 plus solution is 25 milliliters. CO2 plus equals 0.15. EDTA is 0.034. pH is 6. Log Kj equals 16.3. Kj is equal to 10 raised to 16.3. What? Conditional formation constant. What could you start So what is the value PCO2 plus? Oh, we have to find the value, okay. Why is it important in titration with EDTA, in complex symmetric titration with EDTA? For stable complexes with EDTA, EDTA is added during titration by from COY2 plus the concentration of free unbound. There's a line, yeah. Hey Siri, set a timer for 30 minutes.
30 minutes. Counting down.
Counting down, 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 down. So I don't have the mind to do the maths. I'm just gonna read these. To detect and measure a specific antigen present in a sample such as blood, serum, and urine, Sandwich ELISA uses two antibodies, a capture antibody bound to the plate, a detection antibody that binds the antigen to a different site. The antigen is sandwiched between these two antibodies. The detection antibody is usually linked to an enzyme, and a substrate is added at the end that the enzyme converts to a colorimetric and fluorescent signal. To detect and measure a specific antigen target molecule present in a sample such as blood, serum, or urine, a capture antibody bound to the plate, a detection antibody that binds the antigen at a different site. The antigen is sandwiched between these two antibodies. The detection antibody is usually linked to an enzyme, and a substrate is added to an end. Okay. The detection antibody usually links to an enzyme and substrate is added at the end that the enzyme converts to a colorimetric or fluorescent signal. Capture antibody well plated, usually polystyrene, is coated with specific antibody that can bind the target antigen. The plate is incubated and then washed to remove the unbound antibodies. A blocking buffer such as BSA casein is added to block non-specific binding sites. Oh, gosh. Prevents false positives from other proteins like sticking to the plastic. A blocking buffer is added to block non-specific binding sites on the plate. The antigen linked to an enzyme, and a substrate is added at the end that the enzyme converts to. Blocking buffer is added to block non-specific binding sites on the plate, prevents false positives from other proteins sticking to the plastic. Sample addition. The sample containing the antigen is added. Antigen binds specifically to the capture antibody. Plate is washed and removed unbound substances. A second antibody that binds to different epitome of the antigen is added. This antibody is linked to an enzyme. Plate is washed again, remove excess antibody. A substrate specific to the enzyme is added. Enzyme catalyzes a reaction, a color change occurs. The intensity of the color is measured using a spectrometer or plate reader. The result is proportional to the concentration of the antigen. Virtual method used to detect and measure the concentration of specific antigen in a liquid sample. The method is called sandwich. like filling between two fluids. Okay, it's widely used in medical diagnostics research. Okay. The detection antibody binds to anything randomly. The enzymes will still react with the substrate and produce a false. Okay. The signal only appears if the target antigen is present. So when coat the plate with capture antibody, the bottom of the plastic plate is coated with antibody. This antibody is specific to the antigen. Okay. Add the sample. It will bind to the capture antibody. If there's nothing sticks, add the detection antibody. Now add another antibody. This one binds to the antigen, but a different site. It's called the detection antibody. This antibody is linked to an enzyme. It reacts with substrate. So antibody to antigen is target antigen present binds to capture antibody. Oh, it attached to the antigen. Okay, this detection. Now add a substrate. Okay. What was the question? Sample addition. And then you add the substrate. Yeah. An amperometric glucose sensor measures glucose concentration by detecting the electric electric current produced from enzymatic oxidation of glucose. What? Just disconnect? What's that? You can go to the artist. The fuck? Bro, chill. The sensor uses enzyme glucose oxidase, which specifically reacts with glucose present in the sample. The enzyme catalyzes the oxidation of glucose to gluconolactone. Gluconolactone. Electrochemical detection. The hydrogen peroxide produced is oxidized at a working electrode of sensor, generating electrons and electric current. The electric current generated by the oxidation is proportional to the concentration of glucose. Okay. Okay, the glucose releases the peroxide. The sensor electrons measure this current, which is converted into glucose concentration reading. The sensor relies on glucose oxidase enzyme to convert glucose in hydrogen peroxide. The hydrogen peroxide. Okay. Explain the working principles and characteristics of. I'm head to sleep. Yep. I'm gonna go sleep. Wake up morning. Peace out, people.